right. If you don't have essential question, I'll give you another couple seconds to get that written. Okay? So it's how do you use the double angle, the power reducing, the product to sum, and the sum to product formulas. I'm not sure if they're in the front of your notebook, but for sure in the front inside cover of your textbook is a chart with all the trig on it, right? There's more trig identities than what we have on the windows, all right? And that's what we're going to start doing. There's 4 or 5 that we're going to do in this one, and then there's another one that's in 5.4, okay? And then we're done with trig, okay? Yeah. So we'll do this for about a week and a half. We'll take a test. And then after that, we're getting kind of close. I think it's the second or third. It's the third week of May is when we're going to take our final, okay? Because we're going to take it with the seniors. The only other thing we're going to cover is stats. We do a little tiny bit of stats, okay, at the end of this, all right? And if you're thinking of taking AP stats, it's nowhere close to what you would see in AP stats. It's pretty basic, okay? Because if it was like AP stats, I probably wouldn't be teaching it. Stats is not my favorite. Yeah. You can get the rest of the code? I'll put it back up. There you go. Anybody else still need the code? It's up there. All right. Let's go for this. Everybody got the essential question? Okay. So I don't think you have to fill those in. Are they there for you? Do you have to fill them in? They're there. Okay, awesome. So these are what we call the double angle formulas. Okay? The reason it's double angle is because, let me show you here. Let me get a different color going. Okay? Because right in here it's 2 times some kind of an angle. Do you see that? And all that the rest of trig is manipulating equations or formulas to get them to what we want them to be. Okay? Sometimes we use them to evaluate things. Sometimes we use them to verify identities. Those are the only things that are going to happen. Okay? We probably do more evaluation than we do verifying in this section, in these sections. Okay? There'll be a little bit of verifying, but not as much. I don't expect that these ones get memorized, okay? I'm going to give you a chart on the test, so don't freak out. Understand how to use them is more what we're going for right now, okay? So if I have a sine of 2 times some kind of angle, I'm going to use 2 sine u cosine u, okay? If I have tangent times 2 times an angle, I'm going to use this one. If I have cosine, I get to pick. There's 3 different ones that work, okay? Be really careful not to get these mixed up with your Pythagoreans. Okay, because they're a little bit different than your Pythagoreans. The signs are in slightly different places, plus there's a 2 out in front. Okay? All right, so let's look at the first one. All right, we've seen something like this before. Okay? We at least have started something like this before. They want me to use the figure to find the exact value of all of those pieces of trig. So right now, without my help, write down the sine and the cosine. So everybody write down your sine and your cosine. You can do that without my help. Oh, we need an angle, don't we? That would be helpful. Let me see which angle we're supposed to be using. I bet it's the one on the bottom. Yes, use this one as x. So make that x. Everybody write down your sine and your cosine. Okay? All right, what was the sine? 8 over 17. Do we all agree with that? All right, what about the cosine? Everybody okay with those 2 things? Awesome. All right, that was the easy part. Notice all the rest of them are double angle. I didn't give you a double angle for the last 3, did I? What are we going to use to get the last 3? We're going to use our reciprocal identities. Perfect. Okay? So I got to find the cosine, the sine, and the tangent. I am probably not going to... Good morning. All right, thank you. All right, I am probably not going to find a whatchamacallit, a perfect. I'm sorry, I've got mixed up with the guy coming in. I'm probably not going to find I don't know what I was saying. Oh, we're gonna start C there. Let me pass these out because I know some of you are leaving right now. Okay. All right. It says on here if you're into this problem. See if Mrs. Bauer can actually figure out what she's doing. Okay. So here's what you're going to do. Okay. Up at the top of your page, you have your double angle identities sitting there, right? All right. What does it say? We're going to start with the cosine one. Okay. And the cosine says I get to pick whichever one I want, right? So the information that I have is sine and cosine. It doesn't matter which one of the formulas I pick. I can pick any of the ones I want. I'm going to choose to do, it was cosine, is it cosine squared? Let's see. Cosine squared minus sine squared. So I'm going to do the cosine squared formula minus the sine squared formula. So what was the cosine that we found? Yeah, do you see why we did the sine and the cosine first? We're going to use them, right? What's the sine that we found? 8 over 17. And then we're going to square it. Yeah, the calculator is going to be helpful because the numbers are going to be ugly today, right? Okay, there's no way around the ugly numbers. All right, what's 15 squared? 225. Okay, and what's 17 squared? 289. Good. Minus, good news, 289 again, got a common denominator. What's 8 squared? 64. 225 minus 64. 161 over 289. I don't think that reduces at all. So there's your answer for C. All we did was apply a formula. It's not like we've never applied formulas in this class or any math class before. So it's applying a new formula. Okay? All right, let's do D. That was C. I'm going to squish D here. Okay, so D is we're supposed to be finding sine of 2x. So what does the formula say for sine of 2x? 2 sine times, so I gotta do the sine times the cosine. What was the sine that we found originally? Good, and what was the cosine we found originally? 15 over 17, perfect. All right. Looks like we're gonna multiply across the top and across the bottom, right? We already know the bottom's gonna be 289, right? So you tell me what's 2 times 8 times 15? 240. Again, technically we should probably reduce our fractions, but I think that one's probably already done. All right, so that was D. I'm gonna tell you that E is probably the ugliest of the bunch here. The fractions are a little bit more difficult. All right, so tangent of 2x equals. All right, what does the tangent formula tell us? 2 times the tangent over 1 minus the tangent squared. Did we find the tangent originally? Could we read it out of the triangle, though? Yeah, they should have probably had a C and been tangent, but that's okay. All right, what is the tangent of that triangle? 8 over 15, and so we're going to use 8 over 15 here as well. All right, I'm going to do my work going down until I can't go down anymore. All right, what is, let's see, the numerator is going to turn out to be what? What's 2 times 8? 16 over 15, perfect. All right. I'm going to do this part here, and then I'll write down my 1, because I'm going to rename 1 in here in a minute here. What's 8 squared? 64. What's 15 squared? 225. All right, what's a better name for 1? 225 over 225, because we're working with fractions. All right, I don't think I can do my work down anymore. I'm going to have to go to the side here. All right, so I've got 16 over 15. What does my denominator become? 161 over 225. Perfect. Okay. How do I get rid of the double fraction? Multiply by the reciprocal, right? Or we flip the denominator and multiply. All right, how many times does 15 go into 225? 15. I don't think anything else reduces, right? So 16 times 15 is 240. Okay. So that's the answer for that one. All right. Should you be able to do the secant, the cosecant, and the cotangent? Okay, so everybody right now write down those three. Okay? So write down those three. The secant, the cosecant, and the cotangent. You figure them out. All right, what'd you get for secant? 289 over 161. All right, what about the cosecant? 289 over 246. 240. 240. Got to be able to read your own handwriting, right? All right, what about cotangent? 161 over. It's a problem if you can't read your own. There's days I can't read mine though, so that's okay. All right, we good with one? All right, that was probably one of the longer ones we're gonna do. The other ones. That's the only one we're gonna do that's like that though. I'm not gonna go through another one of those whole things because I think you can handle it, right? We're plugging numbers into formulas. You just got to pick the right formula. All right, this one is asking us to find exact solutions of the equation algebraically on an interval. So we're just going 0 to 2 pi. Okay. But see how I've got the double angle in there? I can't really solve it, and plus 1 is a sine and 1's a cosine. What we've learned about this solving thing before is we have to get it either into sines or cosines, okay? I'm going to choose to replace the double angle. So I've got 2 cosine x is going to stay exactly the way it was. I'm still going to be equal to 0. What can I put in for the sine 2x? What's the double angle that replaces it? 2 sine x cosine x. Good. All right, now let's look at it. I'm looking to be able to factor something out. So what's the same in both of those terms? Cosine x, is there anything else that's the same? The 2. So I'm going to factor those things out, just like we would have done a greatest common factor back in September. Or actually August, right? All right, what's the greatest common so we're taking out the 2 cosine x. What's left in that first term? 1. What's left in the second term? Sine x. Now we're back to good old zero product property. Okay, we've been doing zero product property forever. 2 cosine x equals 0, and 1 plus sine x equals 0. All right, I forgot to tell you to get out your unit circles, didn't I? You might want your unit circle out if you don't think you have it memorized and you want to write it down really fast. It's Monday morning, right? We need our unit circles out. Okay, so now that we've got our unit circles out, we're gonna solve it. So what am I gonna do with this 2 here? Divide. So what's 0 divided by 2? 0. Okay, what am I gonna do with this 1? Subtract it, right? All right, so I need to figure out, and remember we're gonna go everywhere on the unit circle. So between 0 and 2 pi, but not beyond the actual unit circle, 1 revolution. What are the 2 places where cosine is equal to 0? I heard one of them. Pi over 2 I like. Where else? 3 pi over 2. Awesome. All we're doing is looking at the quadrant angles, right? All right, what about where sine is equal to -1? There's only one of them. 3 pi over 2. So technically I got a repeated value, right? That's not a big deal. So these guys here are your answers. That one was almost better than the last one, I think. Only because it was shorter. Okay, we're going to do something similar on the next one. The next one's a little bit uglier. A little bit uglier. Okay. So we're going to do sine of 2x. We're going to replace that. So the idea is today we're going to try to replace our double angles. Okay, to get them down and get that 2x out of there. So, what am I allowed to put in for sine 2x? Cosine x, right? That's the new formula we learned. And then I'm going to drop down the sine x that was already there, and I'm going to set it equal to the cosine x that was already there. All right. The goal here is to get it to factor. So that means I want it to be equal to 0 if I'm going to solve something. How am I going to move that cosine to the other side? Subtract it. Oh, what's sine times sine? Sine squared. So I'm going to rewrite that as 2 sine squared cosine x minus cosine x equals 0. All right. Can you hear everybody coming? They can't find the labs. That's what that's about. Because all the labs are hidden inside. All right. What is your greatest common factor here? What's in both of these terms? Cosine x. Good. All right, what can I pull? I'm going to pull that out then. So I'm going to pull out cosine x. And what's left behind? 2 sine squared x minus what? 1. All right. What property are we going to use? 0. Good old zero product property. So cosine x equals 0. And 2 sine squared x minus 1 equals 0. From this step down, it's not anything new. We've been doing this. Okay? So where on the unit circle does the cosine equal 0? Yeah, we just did it, right? Pi over 2 and 3 pi over 2. So there's some of my answer right there. All right, what do we have to solve this one a little bit more. What am I going to do to move the 1? Add it. So 2 sine squared x equals 1. And then what am I going to do to move the 2? Divide it. It's kind of looking like 1/2, but let's be careful. We have that square root to deal with. How do I undo the square? Square root. When I undo the square, don't I make it a plus or a minus? So sine x equals plus or minus 1 over square root of 2. Is that on my unit circle? Technically, but it's not, doesn't look exactly that way. What do I have to do with this first? Yeah. But you know what, you guys? You should be at the point that you recognize 1 over square root of 2 is the same as square root of 2 over 2. Okay? I need to find every single case because what do I have out in front here? So every time my y value is square root of 2 over 2, whether it's plus or minus, I need that number. So what are those numbers? All the pi over 4s. Good job. 5 pi over 4 and 7 pi over 4. Is it possible that I get 6 or 8 answers to some of these questions? It is very possible. Okay? Alright. I'm going to skip over number 4. I mean, did we need the space for number 4 already? Alright, I'm going to do 5, 7, and 8, and we're going to try to get all in 9 and 10. Those are the ones I'm going to do. Okay? And we should be okay on our homework. Alright, let's look at number 5. So I'm going to skip over 4. Let's look at 5. So find the exact solution for the values of sine 2u, cosine 2u, and tangent 2u. Use the double angle formulas. Alright, they gave me the cosine. Notice they told me some other information. They told me where it's valid in. So they're saying that it's in between 3 pi over 2 and 2 pi. So my numbers are valid here in quadrant 4. I'm going to use a triangle to try to figure out my missing side. Okay, so if this is my, I don't know, it's a u, right? What is the cosine ratio in SOHCAHTOA world? Adjacent over hypotenuse. Good. So I'm going to make my adjacent leg 5 and my hypotenuse 13. What is my other leg? 12. Okay. I need to figure out, because they want me to calculate these double angle formulas. I know I've got the cosine. I need to figure out the sine and the tangent to use them in the formulas. So sine of u and tangent of u. What's the sine of that triangle? 12 over 13. What's the tangent of that triangle? 12 over 5. Okay, now, there's a catch. What quadrant did we say we were going to be in? 4. Are sine and tangent values in quadrant 4 positive or negative? Negative. That's the orange ring of your unit circle, right? So I'm going to make both of these negative values. Okay? All right. Ready to apply the formulas? So here we go. Sine of 2u. What does the formula say we got to do? 2 sine times cosine. Okay, what was my sine? Negative 12 over 13. And what's my cosine? 5 over 13. Okay. All right. Let's multiply across. So 2 times negative 12 times 5 is what? Good. And 13 times 13 is? 169. Good. Arithmetic's not bad. It's big numbers, but it's not bad. Okay, that's it for the first part. So now we got to find the cosine and the tangent. So the cosine of 2u equals... Okay, so it doesn't matter which cosine formula I use. We did the sine squared minus the cosine squared before, right? I'm going to do this one this time just to show you something different. So I'm going to do cosine of 2 cosine squared u minus 1. All right, what is my cosine? 5 over 13. All right, what's 5 over 13 squared?
25 over 169.
Good. Let's see. 2 times 25 is what? 50 over 169. What's a better way to write the 1? Good. 169 over 169. All right. What's 50 minus 169? Negative 119 over 169. Again, all we did was apply a formula. All right, I'm going to try to squish my tangent in right here. Okay? So now I've got to find the tangent of 2u. All right, so it was 2 times the tangent over 1 minus the tangent squared, right? All right, what is your tangent? Negative 12 over 5, good. And I'm going to put the negative 12 over 5 in the denominator as well. All right, so what's 2 times negative 12? Negative 24 over 5. 1 minus, what's negative 12 over 5 squared? Over 25. And it's going to be positive inside the parentheses, but I'm doing a minus, right? So it's going to stay negative. What would have been a better way to write that 1? Yeah, I'm going to rewrite it as 25 over 25. Because I want to do the least amount of steps possible. All right, so let's look at the denominator. Negative 24 over 5 divided by, what's 25 minus 144? Negative, is it 119? Yeah. 119 over 25. All right, what's going to happen with that double negative? Cancel to positive. Sorry, I'm kind of squishing into other stuff. And then we're going to flip it and switch to multiplication, right? All right, how many times does 5 go into 25? 5. Is there anything else that's going to reduce? I don't think so. So what do we get for our final answer over 119? 120 over 119. All right. Example 6 is almost identical. You're just starting with the sine versus a cosine. Okay, so I'm not going to do a second one of those. Let's look at 7, 8, 9, 10. Okay? They're a little bit shorter. Good news. All we have to do is rewrite the expression. Awesome. We don't have to solve anything. We just have to rewrite it. This is done in 2 lines. Okay? So, we're going to notice there isn't a double angle in there, right? We're going to add the double angle in this time. So I'm going to use the formula backwards. Okay? I'm looking at, I have a sine times a cosine. So one of them was this, right? Sine x, cosine x. That's what sine 2x looks like, right? So I'm going to try to create that instance up here because I don't have this 2 sine x cosine x yet. So I'm going to rewrite this as 2 times 2 sine x cosine x plus 1. Then do you see how this piece here is the double angle? So I'm going to replace that with sine 2x. So 2 from the original, sine 2x plus 1. That says sine 2x plus 1. That's it. That's all they're looking at you doing. Okay, and that's 2x not squared. All right, let's look at example 8. I'm going to try to FOIL that first. But what's special about that one?
Conjugate.
They're conjugates, so what do I really need to do? First and last only, so it's good to recognize those things. What's cosine times cosine? Cosine squared x. What's sine times negative sine? Negative sine squared x. Okay, everybody go back and look at your double angle formulas right now. See if you have one that is equal to cosine x, cosine squared x minus sine squared x. What's equal to it? Cosine 2x. Done. Okay. Alright. Here's we're gonna try to do 9 and 10. We're gonna do a couple more another set of formulas. Okay. Alright. These are called the power reducing formulas. We end up using the cosine one a lot in BC calculus at one point of the year. It isn't something that you're going to use next year, but at least you have seen it before by the time you hit your second year calculus, okay? They're all very similar, aren't they? One of them has a minus, one of them has a plus, one of them has the minus over the plus, okay? You're going to use the one that applies. You know you're going to use power reducing because you're in something squared and you need to get that power out of there, okay? It says rewrite, so these are what the typical instructions look like. Rewrite the expression in terms of the first power of cosine, okay? So I'm going to take this and I'm going to break it into, I know I can't replace sine to the fourth, but I know I can replace sine squared. So I'm going to write as sine squared x squared. Alright, and this one does get a little messy. Alright, what am I allowed to put in there for sine squared? What does the power reducing allow us to put in? 1 minus cosine of 2x over 2. Alright, so what that's really saying, okay, is that I have 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. So now I need to multiply those together. What am I going to get in the denominator? 4. I'm going to write that as a 1/4 out front. Okay, so I'm taking the denominator and I'm pulling it out front. I need to FOIL the middle, or the numerator, right? So what's 1 times 1? 1. What's 1 times negative cosine 2x? How many of those am I going to have? 2. So again, this FOILing isn't working any differently than other FOILing did. What's cosine 2x times cosine 2x? You don't touch the number in the middle. You just do cosine times cosine is cosine squared 2x. Alright, here's the problem. Am I in the first power of cosine? I just went to the second power of cosine, so now I need to replace this thing right here. Okay? That's where this one got messy. So 1/4, 1 minus 2 cosine 2x plus, and now I'm going to put a power reducing in here. Okay? So what's the power, what does it say for the power reducing? I know I divide by 2. What's out front? One plus what? Cosine 2u, right? Okay, let me use a different color so you can see. This piece in here is the u. So what would I'm going to have to put 2 times 2x gets replaced in there. Okay? Alright. The book is going to take this. Technically, you have it in single powers of cosine. I'm going to show you the algebra that the book does to get to their answer. I'm not sure we would take it this far on a test because it gets a little bit uglier. I'm going to move my work up to the top here. Okay? So I've got a 1/4 hanging out. Just bear with me on the work. 1 minus 2 cosine 2x. I'm going to split this into two fractions here. So plus 1/2 plus cosine, I'm going to put the 2's together, 4x. I'm going to put a 1/2 and then make it a 1/2 instead of an over 2. So all I did was split this into two fractions. Alright, my instinct says distribute, but I'm not going to do that quite yet because I want to put the 1 and the 1/2 together. Technically, isn't that 2 halves? So it's 2 halves plus 1/2. 3 halves minus 2 cosine squared x plus 1/2 cosine 4x. What's the last step, do you think, to get a book answer? We're going to distribute. So we'd have 3 over 8 minus, what's 2 over 4 going to reduce to? 1/2 cosine squared x, and then 1/4 times 1/2 is 1/8 cosine 4x. Alright, we're going to do one more. The next one's not as bad. We should have probably done the next one first. Alright, let's look at the next one here. Alright, it says rewrite the expression in terms of the first power of cosine again, so I've got to get this replaced. Remember, this is the u. Okay? So, what does cosine squared turn into? What does the formula say? Two u over 2. What am I going to put in for the u spot? 2x. Whatever's in here. Okay? Okay, let's see if we can simplify to get what the book answer would be. Alright? I'm going to do a couple things at once. I'm going to split up the fraction like we did in the last one. So 1/2 plus 1/2 cosine. Instead of writing 2 times 2x, what are we going to write? 4x. Great answer. Is it possible that they get tricky and factor out a 1/2? Both of those are great answers. Okay? I would take either one of them on a test. I may even take the first line on a test, depending upon how generous I'm feeling. Oh, that is a giant bug. Alright. We need a nice brave boy to kill that for us. Don't move. It's, I don't know what it is. I don't think it's a spider.
No, I don't know what that is. It's not a spider.
No, I'm not sure what that is.
That was nice.
Oh yeah, go Miss
I'm
Valerie.
not taking my shoe.
Oh yeah. Smack that man.
Because I don't want its eggs coming home. Right? Okay. I think it's dead now. I'll scoop it. Okay. We're good. The bug is giant and dead. It's better to have a dead giant bug than a live giant bug. Alright, I'm going to hit publish on this. Okay, so go ahead. There should be a new page in Haiku right now. Okay? I'll pick up the dead bug. Okay? I'll throw the dead bug away. See, ladies, none of those boys got up and helped us, did they?
Yeah.
I don't want extra credit. Chivalry. All